Today, we're starting our next unit with, we're just talking about what does it mean to be a relation versus a function. So you're going to notice that we are dealing with a lot of different types of problems when it comes to this unit, which is all about functions in general. So before we get into like, what's the difference between the two, we're going to start off with just a basic graphing review. So we're going to see kind of what you remember. Mainly, what I want you guys to do right now is all I want you to do is see what you know about, about question number one. I want you guys to, right now, I want you to label this graph over here with each one of those pieces. So I'm going to have you pause your video. I want you to just give it a shot, see if you can remember where those things go, and then we will get going. All right, let's see how you did. So I started off by putting all the quadrants in there. So remember, when we talk about quadrants, the prefix quad literally means four. And a graph is always divided kind of into four main regions. So the kind of like this upper right square, we call that quadrant one. And it's just a place where different points could fall. Quadrant two is really like, it's kind of like the upper left one from the middle, basically. Quadrant three, I always remember that it always moves in a counterclockwise rotation. So it goes from quadrant one over to quadrant two, down to quadrant three, and over to quadrant four. So when it comes to the different types of quadrants, those are the locations of those. Now, part E, I said label the X and the Y axis. You're in luck because I did that for you. So the y-axis, that's what we call kind of the vertical axis. Y always represents kind of like the up and down directions of any graph. And the x-axis represents kind of like the horizontal movement of any point. And the origin is probably one of the most used points in all of Algebra 1. And the origin is just simply the place where the x and the y-axis meet. And so we call it the origin, but its ordered pair, and this is something we're going to talk about in a minute, its ordered pair is going to be at 0, 0. Now, if you looked at question 2, it says, how do you write the ordered pair of any point on the graph? And I kind of gave you a hint, but it's always notated in kind of the same format. So if I have the ordered pair, it's always x is kind of like the first number. Basically, an ordered pair is made up of two numbers. X represents the first one, and the y value represents the second piece. And these tell you specifically kind of like which directions you want to move. So x is always kind of, x is always the right or the left direction that you're going to go. So if it's to the right, it's positive, and if it's to the left, it's negative. And the y coordinate, whatever number is listed second, that tells you how far up or how far down to go. On a graph, up is always the positive direction and down is always the negative direction. So it kind of keeps in mind, like, for example, in order to get into quadrant 1, really you have to go right and then up, which means that whatever numbers you have, they really both have to just be positive in order to end up in quadrant 1. In order to end up in quadrant 2, you have to go a little bit of a different direction. We start at the origin, and in order to get actually into quadrant 2, I have to go left, I have to move left, and then I have to move up. So to get into quadrant 2, left on a graph, left is the negative x direction, and up is the positive y direction. To get into quadrant 3, this one I have to go left and then down. So I have to go left, which is negative. Left and down essentially are always going to be your negative answers. Okay. And quadrant 4, I go right, which is positive, and I go down, which is negative to get into this guy. So when it comes to our quadrants, when we list out specific numbers, it helps us find those pieces on a graph. It's a location of that point. And a lot of times we'll name it. So like these three, I named the points F, G, and H. Our goal is going to be, I'm going to label each of those on a graph. So I'm going to do F first. So F is -5, +6. So what this tells me is I essentially want to move left 5 and I want to move up 6. So I'm going to it's always measured from the origin. So I'm going to go left 1, 2, 3, 4, 5, up 2, 3, 4, 5, 6, and that right there is the location of point F. And usually if it has a name, we're always going to label it and put it on the graph next to the ordered pair. Okay, so you don't need all of these little points right here. Those are just so I can count. But let's do another one. So 0, 8, this one is a little bit weird. This one means I'm gonna go left or right 0, but I'm gonna go up 8. If 8 is positive, the positive y direction is up. So I'm gonna start at my origin, and I'm gonna count 1, 2, 3, 4, 5, 6, 7, 8. This one's almost going off the grid, but that right there is where point G is. Now, technically a question that I could ask you later on, I could say like, what quadrants are either of these two in? Well, F, since I went left and then I went up, F falls in quadrant 2. But point G doesn't exactly fall really in any quadrant. Point G really falls straight on the y-axis. So if it's on an axis, you don't actually fall in any particular quadrant. It's simply just that it's on the y-axis. And then point H, what I want you guys to do, I want you to pause your video and I want you guys to try plotting point H. All right, answers up. Hopefully, if I zoom in on it, hopefully this is where you plotted point H. H was at, H is at -5, -6. So that tells me I need to move left 5 and down 6. And this right here is the location of that. All right. So when it comes to plotting points, that's eventually going to kind of come into play with what we're going to talk about next. But before we get into kind of some of the fun examples for today, we do have to spend a little bit of time talking about a little bit of vocab. I'll promise it'll go quickly. But first we have to really just talk about the whole unit is about functions. So what does it mean to essentially be a function or a relation? And really, you're probably, hopefully you heard the word relation and you kind of associated that with relationship. And that's basically what it is. It's a comparison between or of two sets of numbers. So a lot of times like graphing, we start with graphing because graphing really compares kind of two sets of numbers. It compares the x values to all the sets, to all the y values. So in order to have a relation, you have to compare two sets of numbers. Within those two sets of numbers, pretty much anything out there in the world is a relation. For something to be a function though, function is something that's a little bit more specific. Here it's where each x value has exactly one y value or is matched with exactly one y value. So like this actually up here right now is not a function. And we'll talk about why that is. But in terms of like when we plot points, in order to be a function, each x value can only have one y value. So we're going to get into that in just a moment. But before we actually get talking into like functions, there's two words you're going to hear a lot in this unit. Not quite as much, a little bit today, but nothing like crazy. And that is the words domain and range. And just so you guys know, these are pretty much just other words. Instead of saying x values and y values, we could say domain and range. And domain basically just means a list of all the possible input values, which are really just our x values. And the range is basically a fancy word for output, or it's a fancy word for y values. So if I ever say find the range, I'm just saying what are all your y values. If I say what's the domain, I'm saying what are all your x values. Now we'll get into the vertical line test in, like I said, just a little bit, but basically the vertical line test is a way to test if something is a function or not. And it basically involves just drawing a vertical line anywhere on the graph. And if it intersects more than once, then the graph does not represent a function. Okay, so it can only intersect at one point at any time in order for it to be considered a function. So let's actually start looking at the different types of things that we can do. There's really kind of like four main ways that we can display information for functions or relations. And the first one is obviously probably the most common, and that is an ordered pair. Now, if it's an ordered pair, remember, that each one of these guys, no matter which way I give you the information, we can write the other three ways. So the main four ways are ordered pairs. We can draw or create a table of that information. We can graph that information, and we can create something called a mapping. So the first thing we're going to create is a table. And a table, another term you'll hear for this is a table of values. And basically what this means is instead of displaying it kind of like horizontally left to right like we do here, instead of looking at the individual groups of numbers, each one of those are ordered pairs, we're going to display them and kind of group the X values together and group the Y values together. So a table of values will always have usually the X values on the right and the Y values on the left. Well, reverse that. X values on the left, Y values on the right. And that's exactly what we're going to do. So we're going to take each one of these sets of ordered pairs and we are going to rewrite them. So for example, my first one is the ordered pair 1, 2. So in this ordered pair, 1 is the X value and 2 is the Y value. So I'm going to place those across from each other in their own respective columns. And I'm going to do that for each set of ordered pairs. So my second ordered pair, -2 is the X value and 4 is the Y value. So I'm going to put those across from each other as well. And same thing with my last one. 0 is my X value, -3 is my Y value. So 0, -3, I'm going to fill in like so. And voila, you have your table. Now, a lot of times, just so you guys know, sometimes people will put these in numerical order with the X value going from least to greatest. So like, for example, technically the 0, oops, nope. Technically, the -2 is the smallest value. So really -2, 4 a lot of times will come first. The next one would come with 0. So 0, -3 should come second, and 1, 2 should come third. Honestly, either way you do this, it doesn't really matter. Both of these graphs, or excuse me, tables are fantastic, okay? Now, if you're gonna take that information and actually now move it into a graph form, it basically just means we're gonna plot each of these points. So my first ordered pair that I'm gonna graph is gonna be 1, 2. So that tells me I'm gonna go right 1, and I'm gonna go up, right 1, and I'm gonna go up. They added a new feature and I'm not quite used to it. Sorry, guys. So then I'm going to go right 1 and then I'm going to go up 2. And this right here is where my ordered pair should be. And I'm going to label it. And that's going to be my ordered pair 1, 2. And I'm going to do that with all three of them. So let's do the next one. So my next one that I'm going to do is going to be -2, 4. So that tells me I'm going to go left 2 and I'm going to go up 2, 3, 4. And my next ordered pair is going to be here. All right, so that guy's gonna be at -2, 4. And my last ordered pair that I'm gonna graph is gonna be 0, -3. So I'm gonna go left or right 0, but I'm gonna go down to 3. And that is my last ordered pair. And you just created a graph of the information. Now, and I know these two are probably the most similar. When it comes to ones like tables and mappings, they actually look pretty similar. A mapping, what it does is it kind of like uses bubbles. So for example, it has an X bubble and it has a Y bubble. And instead of like in a table, instead of placing things like we did here across from the ordered pair that they go, in a mapping, that doesn't matter. Like if you wanted to do -2, 1, 0, basically all of your X values have to go in the X bubble. And all of your Y values, they could be random. I could do a 4, -3, and 2. At the end of the day, though, you're going to use arrows to represent where they go. So, for example, if I look here, 1 is supposed to go to 2. So using arrows, I'm going to do exactly that. I'm going to draw an arrow from 1 to 2. And then -2 is supposed to go to 4. So -2, I'm going to draw across and draw it to 4. And 0 is matched to -3. So I'm going to use an arrow that goes from 0 to -3. And those are really kind of the main 4 types of relations that I could have you guys graph. Now, you're going to see example 1 and you're going to see, well, determine if each relation is a function. Well, really, this is a different question to ask. 90%, 99% of the time, anything is going to be a relation because you're taking one set of X values and you're comparing it to a set of Y values. But in order for something to be a function, we have to follow a pretty specific set of rules. And you can either think of it using the vertical line test, or you could think about it in another way. Basically, what this means is that every X value maps to only one Y value. So if this might be an easier way to think about it for most things, but you can also use the vertical line test, which we'll talk about in a little bit. But for this one, every X value only maps to one Y value. So like, for example, something that would not be considered a relation is part B. If you look at part B, we're looking at each of these numbers. So -5 is being mapped. This guy right here is a mapping. So if you want to look, because we're using arrows to represent where they go. So -5 is mapped to 2. So -5 only is mapped to one value. 7 is mapped to one value, but 8 has 2 arrows going from it. 8 is currently being, -8, excuse me, is being mapped to -6 and to 1. And in function world, that is not okay. That just tells me that this is not considered a function. Because you have, even if it's only one value, we have -8 that's being mapped to 2 different values. Now, most of the time, it depends. If I'm gonna look at, so for example A, all I was saying is look at the example above. So you can look at this in ordered pairs as well. If I look at the actual ordered pairs of this, let's look at it. And I really wanna look at my X values. So I go ahead and I like to circle them. So we have -2, we have 1, and we have 0. Since every one of those values, 1 is only mapped to 2, there's no other X values of 1 in here. -2 is mapped to 4. -2 doesn't map to any other values that I know of. And 0 is mapped to -3. So each of those X values are mapped to their own individual Y values. So that is a relation that is also a function. We would say yes, totally is going to be a function. So what I want you guys to do, I want you guys to pause your video and I want you guys to determine if part C is a function. All right, hopefully you got yes as your final answer. This is a table, it's just listed horizontally instead of vertically. But either way, if you're gonna talk about what's being mapped to what, 0 is being mapped to 1, 2 is being mapped to 3, 5 is being mapped to 0, 8 is being mapped to 7, 9 is being mapped to 4. Each one of these X values they're not repeated. And each one of those, each individual X value is only mapped to one Y value. So in terms of, is it a function? Yeah, totally is gonna be a function. If you had, for example, like for this one, what would make this one not be a function is, let's say we had another ordered pair that was part of this. And let's say it was like 0, 2. The fact that you would have that 0, 2 as part of this lets you know that then this would not be a function, because 0 is being mapped to 1 and it's being mapped to 2. So that's a case where you have one X value that's going to 2 different Y values. That can't happen. So that would be something where you would create something that's not a function, but obviously that's not part of this one. This one ends up being just a regular old function. So what I want you guys to do is I want you to pause your video and I want you guys to try determining if the you try nows at the bottom of this page, if any of those are functions and which ones are not. Go. If you would like to wait, we are going to do some of these in class as well. But as always, you guys, if something above didn't make sense, you guys know the drill. Please make sure you email Miss Hardy and set up a time to meet. Thanks, guys.